So we're now into the second section of chapter 7, which deals with proportions and applications of proportions. All right. So what are proportions? We actually talked about them a little bit in the first section when we did those bird problems and the passing and failing student problems. They're really just equalities of two ratios or rates. Okay. So I gave you three examples here of proportions, right? So one of them would be 5 ounces is to 2 ounces, as 10 ounces is to how many ounces? Well, from 5 to 10, I multiplied that by 2. So I do the same thing with the 2, multiply by 2, and I would get 4 ounces, right? So 5 ounces is to 2 ounces, as 10 ounces is to 4 ounces. 70 miles per 1 hour equals how many miles per 2 hours? Well, similarly, I just multiplied by 2 here to get from 1 hour to 2 hours. So I do the same thing on the top. 70 times 2 would give me 140. So 140 miles per 2 hours. And then this one is a little bit more complicated. $1.50 for how many eggs is equal to $0.125, right, which is 12.5 cents per one egg, right? So if I wanted to see, because it's not obvious how I got from 0.125 to 150, you could check that by division. So if I did 150 divided by 0.125, I would find that I actually multiplied by 12, right? So really to get from this to this, I multiply by 12. So I would do the same thing here, multiply by 12, and that would be 12 eggs. So it's $1.50 for 12 eggs is the same as $0.125 per egg, right? So those are all what we would call proportions. They are qualities of two ratios or rates. So when we have a basic proportion, if we wrote it in this form, what would we read that as? We could read that as A is to B as C is to D, which I think I did up there with the 5 ounces is to 2 ounces as 10 ounces is to 4 ounces, right? So that's how we would read that. A is to B as C is to D. And A times D and B times C, we call those things cross products. Why cross products? Because you're multiplying diagonally, right? A times D, B times C. So we call those cross products. So if we're going to try to solve for a unknown in a proportion, or just to determine if two ratios or rates do form a proportion, we're actually going to use cross multiplying, right? So what is cross multiplying? It basically is setting the two cross products equal to each other, right? So A times D and B times C. So then if we have a basic proportion, A is to B as C is to D, then B times C equals A times D. Okay, so what you could do with these is you could say, all right, well, is, I don't know, 7 to 11 the same as 11 to 15? I don't know, right? Is that a proportion? Is it a proportion? Well, you would just use your cross multiplication to check, right? Do your cross products. A is 7, D is 15, so 7 times 15, and B and C are both 11, so 11 times 11. So you'd basically just be asking yourself here, is 7 times 11 the same as, I'm sorry, 7 times 15, is 7 times 15 the same as 11 times 11? I don't know. Well, 7 times 15 is actually 105, and 11 times 11 is 121. So 105 is definitely not equal to 121. So that's not right. Therefore, no, it's not a proportion. So when you're testing for a proportion, you're basically just cross multiplying and making sure that the cross products are equal. So how about another one? Is 2 to 7 the same as 5 to 17.5? Is that a proportion? I don't know. Again, do your cross multiplying. So is 2 times 17.5 the same as 7 times 5? Well, 2 times 17.5 is just 34 plus 1, which is 35. And 7 times 5 is also 35. So that actually works. So yes, 2 is to 7 as 5 is to 17.5. That actually is a proportion. Okay, so there we just did some checking